Hello, welcome to Astronautics for Exploit. This is Dr. Anyashola Ogundele. Imagine a new technologies of Mars exploration, technologies for liberating humankind from being earthbound. The focus points of my presentation are as follows. Imagine a new technologies and imagine a new technologies of Mars exploration. For many decades, the concept of Mars colonization has been depicted in various science fiction books and novels. Presently, the concept is receiving high attention from space enthusiasts, government space agencies, and private space companies. As a result, a lot of efforts are being directed to invest in and develop new technologies that will aid actualization of eventual colonization of Mars. For better understanding of the universe, investment in various space activities is very crucial. Over the years, space exploration investments have helped to spur innovation and the development of new and emerging technologies. This, in turn, has aided science advancement, springing up of various private space companies, creation of employment, solved some of the human curiosities about space, development of spin-offs, and provision of economic benefits for humankind. Each of the Mars exploration missions contributes to the evolution of new and emerging Mars technologies. Various lessons learned from the technologies developed for the previous Mars exploration missions contribute significantly to the development of new, cutting-edge and next-generation technologies for the future missions. This helps to push the space exploration boundaries. For example, much of Perseverance rover design, including its entry, descent, and landing system, are directly inherited from the Curiosity rover, which landed on Mars in 2012. Perseverance carries new technology demonstrations and improved entry, descent, and landing technologies, which will help to pave the way for future robotic and human missions to the Moon and Mars. Various emerging and new technologies of Mars exploration are being proposed. The Mars Oxygen In Situ Resource Utilization Experiment, or MOSI, is helping NASA to prepare for human exploration of Mars. MOSI was designed to test a way that future explorers can produce oxygen from the Martian atmosphere for burning fuel and breathing. The Ingenuity Mars helicopter, which has completed 51 flights since first taken to the skies above the red planet on April 19, 2021, far exceeding its originally planned technology demonstration of up to 5 flights, was the first aircraft to achieve powered controlled flight on another planet, a feat that has been called the Wright brothers moment. Imagine our new technologies. Space exploration. Imagine and new technologies are being developed for the purpose of helping humanity to explore the space and break boundaries. Presently, various efforts are being made by the government space agencies and private space companies and academia to develop new and emerging technologies for the exploration of Mars. The picture here shows illustration of a pressurized rover on Mars with breathable air. Imagine and new technologies of Mars exploration. Some of the emerging and new technologies of Mars exploration are in situ resource utilization, Ingenuity Mars helicopter technology, propulsion technologies, inflatable heat sheet technologies, entry, descent, and landing technologies, high-tech Martian spaceships, uninterrupted power technologies, and laser communications. In situ resource utilization. In situ resource utilization is the practice of collecting, processing, storing, and use of resources found or manufactured on other astronomical objects such as the Moon, Mars, asteroids, old spacecraft that replace resources that would otherwise be brought from the Earth. In situ resource utilization is a suite of concepts and technologies that can enable safer and more cost-effective use of space by exploiting local future human missions to Mars. Mars Oxygen In Situ Resource Utilization Experiment is shown in this picture. MOSI, the Mars Oxygen In Situ Resource Utilization Experiment, is a technology demonstration on the NASA Mars 2020 rover Perseverance, which is investigating the production of oxygen on Mars. On April 2021, MOSI produced oxygen from carbon dioxide in the Martian atmosphere by using solid oxide electrolysis. An artist's concept of base infrastructure on Mars is shown in this picture. The MOSI instrument, located inside the body of the rover, was designed to test technology that converts carbon dioxide in the Martian atmosphere into oxygen using local resources found on the planet. The MOSI technology demonstration is very important for future human missions to Mars. The MOSI experiment was the first experimental extraction of a natural resource from another planet for human use. An artist's illustration of an early Mars settlement is shown in this picture. Ingenuity Mars Helicopter Technology. The Mars helicopter Ingenuity is a technology demonstration to test the first powered and controlled flight on another world for the first time. The helicopter rode to Mars attached to the belly of the Perseverance rover. It was launched on July 30, 2020 at Cape Canaveral Air Force Station, Florida. Once the rover reached a suitable airfield location, it released Ingenuity to the surface so that it could perform a series of test flights over a 30 Martian day experimental window. Mars helicopter is shown in this picture. Propulsion technologies. Advancements in propulsion capabilities are the key to reaching our destination as quickly and safely as possible. Different propulsion technologies are being proposed for Mars missions. For the purpose of reducing travel time, nuclear-enabled propulsion system is proposed. Presently, nuclear electric and nuclear thermal propulsion technologies are under development. Both make use of nuclear fusion, but are very different from each other. A nuclear electric rocket is more efficient, but it doesn't generate a lot of thrust. Illustration of a spacecraft with a nuclear-enabled propulsion system is shown in this picture. Inflatable heat shield technologies. An inflatable heat shield, unlike traditional rigid heat shields, can be packed to a very small size and then deployed to a scale much larger than a rocket's payload fairing. A demonstration of an inflatable heat shield or aeroshell, low Earth orbit flight test of an inflatable decelerator is the next step in advancing inflatable heat shield technology, which could one day help land humans on Mars. Illustration of low Earth orbit flight test of an inflatable decelerator is shown in this picture. NASA is working on an inflatable heat shield that allows land surface area to take up less space in a rocket than a rigid one. The technology could land spacecraft on any planet with an atmosphere. It will expand and inflate before it enters the Martian atmosphere to land cargo and astronauts safely. The Loft Reentry Vehicle, which comprises of the inflatable structure, is shown in this picture. Entry, descent, and landing technologies. The Mars 2020 rover mission uses various new technologies during entry, descent, and landing, such as range trigger for precise timing of the parachute, terrain relative navigation to help avoid hazardous terrain, and advanced aeroshell sensor package to record what the spacecraft experiences during landing and how it performs. The picture here shows the range trigger techniques, which significantly strengthens the rover's landing ellipse. Descent cameras and microphone. Perseverance also carries a new suite of descent cameras and a microphone for documenting the signs and sounds of landing. Terrain relative navigation is critical for next generation Mars exploration. Some of the most interesting places to explore lie in challenging terrain with hazards like steep slopes and large rocks. This simulation depicts the terrain relative navigation technique incorporated into entry, descent, and landing for the Mars. High-tech Martian spacesuits. Spacesuits are essentially custom spacecraft for astronauts. NASA's latest spacesuit is high-tech and its modular design is engineered to be evolved for use anywhere in space. The first woman and the next man on the moon will wear NASA's next generation spacesuit, which is referred to as Exploration Extravehicular Mobility Unit. The spacesuits prioritize crew safety and allows atomic generation moonwalkers to make more natural, Earth-like movements. The picture here shows prototypes of the Orion crew survival suit. Uninterrupted power supply technologies. Astronauts need a reliable power supply to explore Mars. The system will need to be lightweight and capable of running regardless of its location or the weather on the red planet. Mars has a day and night cycle like Earth and periodic dust storms that can last for months, making nuclear fusion power a more reliable option than solar power. NASA plans to demonstrate and use the fusion power system on the Moon first before the Mars. Illustration of a nuclear fusion power system concept on Mars is shown in this picture. Laser communications. Human missions to Mars may use lasers to stay in touch with Earth. A laser communication system at Mars could send large amounts of real-time information and data, including high-definition images and video feeds. Sending a map of Mars to Earth might take 9 years with current radio systems, but as little as 9 weeks with later communications. The technology will also allow us to communicate with astronauts so as to see and hear more of their adventures on the red planet. Illustration of a spacecraft using laser communication to relay data from Mars to Earth is shown in this picture. For more information, contact Astronautics for Exploits. You've been watching and listening to Imagine and New Technologies of Mars Exploration Technologies for Liberating Humankind from Being Earthbound, with the focus points Imagine and New Technologies and Imagine and New Technologies of Mars Exploration. Thank you.